Welcome back. In this video, we are going to solve a structural design problem that involves an isolated footing design using LRFD method based on eStructural Design Zen found on the App Store. Design an isolated rectangular footing using load and resistance factor design for a 300mm by 300mm square column carrying an axial dead load of 400 kN and axial live load of 360 kN. Design criteria as follows: strength of concrete 35 MPa, main bars 16mm bar grade 414, soil bearing capacity 240 kPa, approximate dimension ratio of 1:2. The footing carries an axial dead load of 400 kN and axial live load of 360 kN for a factored load of 1056 kN. Enumerate input parameters required. Footing name F15, shape of footing rectangle, depth from natural grade line 1500 mm, long direction bars 16mm bar at grade 414, short direction bars 16mm bar at grade 414, strength of concrete 35 MPa, soil bearing capacity 240 kPa, column size 300mm by 300mm, and factored axial load 1056 kN. Given allowable soil pressure equals 240 kPa, depth from natural grade line equals 1500 mm, and assumed footing depth equals 420 mm, the effective soil pressure is 212.64 kPa. Given axial dead load equals 400 kN and axial live load equals 360 kN, the footing width is 1.34 meters and footing length is 2.67 meters. The effective soil pressure is 295.153 kPa. Critical section diagrams for punching shear, beam shears, and moment evaluations. At long direction, given ultimate soil pressure equals 295.153 kPa, footing width equals 1.34 meters, footing length equals 2.67 meters, and column side equals 300 mm, the maximum moment is 277.689 kN/meter. Given resistance factor equals 0.9, P equals 1340 mm, and D equals 337 mm, the beam design ratio Rn equals 2.027 MPa, and reinforcement ratio Rho equals 0.00508. Continue at long direction. Given Rho equals 0.00508, B equals 1340 mm, and D equals 337 mm, the area of steel for long direction bars is 2294.03 square millimeters, and the number of bars for 16mm bar is 12. At short direction, given ultimate soil pressure equals 295.153 kPa, footing width equals 1.34 meters, footing length equals 2.67 meters, and column side equals 300 mm, the maximum moment is 106.546 kN/meter. Given resistance factor equals 0.9, L equals 2670 mm, and D equals 337 mm, the beam design ratio Rn equals 0.39 MPa, and reinforcement ratio Rho equals 0.00095. Use Rho minimum of 0.00357. Continue at short direction. Given Rho equals 0.00357, L equals 2670 mm, and D equals 337 mm, the area of steel for short direction bar is 3212.25 square millimeters, and the area of steel at center strip is 2146.84 square millimeters, and the number of bars for 16mm bar is 11. The area of steel at outer strip is 532.7 square millimeters, and the number of bars for 16 millimeter bar is 3 on each side. The factored beam shear force at long direction is 335.388 kN. The nominal force is 447.184 kN, less than 454.169 kN concrete capacity. The factored beam shear force at short direction is 144.215 kN. The nominal force is 192.287 kN, less than 904.949 kN concrete capacity. The factored punching shear force is 936.234 kN. The nominal force is 1248.312 kN, less than 1676.399 kN concrete capacity. Design recommendation as follows. FC prime equals 35 megapascal, Fy equals 414 megapascal, Qa equals 240 kilopascal. Footing size is 1340 mm by 2670 mm by 420 mm. Depth of footing from natural grade line 1500 mm. Long direction bars of grade 414, 12 pieces 16 mm bar at 108 mm on center. Short direction bars of grade 414, center strip bars 1340 mm wide, 11 pieces 16 mm bar at 119 mm on center. Outer strip bars 665 mm wide each side, 3 pieces 16 mm bar at 222 mm on center each side. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.